So this is going to be the second of three parts, and the kinds of problems that I'm going to factor are exactly the same in the second part as in the first part, but instead of using grouping, I'm going to factor by site factoring. So the strategy that we did for problems 1 through 28 is slow, and there's a quicker way that's almost the same to solve these problems. And the method I'm going to show in this video is what I exclusively use when I factor problems that have polynomials that have three terms with a 1 in front of the square term. The reason we do the first 28 problems is because that technique is going to be used if there's not a square term in front of, if there is a number in front of the squared term. So it's an important technique to learn when the problems are a little less complicated, so that as the problems get more complicated in section 5.4, that the transition isn't so bad. So I'm going to pretend like I'm going to factor by grouping. If I was going to factor problem 30 by grouping, if I was going to take the time to rewrite it by grouping, I'd look at my template, and my template says if the problem has pluses and plus, you need double pluses for your factors. So now I'm going to write down the plus factors of 50. I'm going to take that same last number, nothing new, and I'm going to write the factors of 50 that are both positive. So 50 is 1 in 50, 2 in 25, 5 and 10. First step, exactly the same. Technically, it's the second step because I'm looking for common factors on the first step, of which there aren't any to the third video. Next step, exactly the same. Let's add these numbers up. 1 plus 50 is 50. 2 plus 25 is 27. 5 plus 10 is 15. Nothing new at all here. Found the pair that I need. This pair gives me the 15. What's new is I didn't need to go through all that business of grouping. What I'm going to do is I'm going to create two parentheses. And now I'm going to have to be just the slightest bit clever. In the first positions in each parentheses, I'm going to take the y squared and split it up evenly by dividing its exponent by 2. So the y squared had an exponent of 2. I'm going to divide that exponent by 2 and get a y to the first. And then the numbers that I know I need to use along with their signs are going to be stuffed in my parentheses. So rather than splitting this up into 4 terms, doing grouping factoring, I'm cleverly picking out the firsts by dividing the exponent of this first term by 2. And the numbers with their signs are going to go in the parentheses. I claim that's my answer. So I don't have to go through the grouping if there's not a number in front of the squared term. Let me show you that this checks, that this actually equals what it needs to. I'll do foiling. I'll do first times first, and then outers, y times 10, and then inners, 5 times y, and then lasts, 5 times 10. This is going to give me y squared plus 15y plus 50, exactly the original problem. So it's almost like grouping without doing the grouping. We just have to figure out what to put in the first position because the algebra off to the side tells me the numbers that go in the last positions. Let us do 33 together. Again, I'm not going to do as many problems as I have written. I have too many problems written. So immediately on 33, I was kind. I made nice, lovely positives, which is the best kind of factoring. When there aren't any negatives, your choices are only to use positive numbers. So, because the signs in the original problem are both plus, my factors of 8 need to both be plus. So when I go to worry about the constant, I'm going to write its factors down, double positives, 1 and 8 and 2 and 4. That's the equivalent to the first step that I was doing by grouping. Now I'm going to add the numbers. 1 plus 8 is 9. 2 plus 4 is 6. I'm shooting for that 6, so I'm going to need the 2 and 4 pair. Claim that I've got enough to factor. I'm going to create 2 parentheses. I'm going to take the exponent of the r and divide it by 2 and split that evenly, that result, into the firsts from both parentheses. So r to the 2 divided by 2 would give me r to the 1 power, which is just r. That's going to lead off my parentheses. The numbers that I use along with their signs need to go in my parentheses. I have a positive 2 and a positive 4. So that would be an answer for 33. This would be an answer for 33. They'll check. Again, checking takes long. I like to check, but I actually like to get volume done too, so I'm not going to check that one. Do one problem on each page to keep the video appropriate length of time. So I'm going to work on 36. 36, that's the second row of my template. The signs in the original problem are minus first and plus second. So when I'm writing down the factors of 12, I need them both to be minus. So I'm going to, for my 12, find the factors of 12, make them both negative. My factors of 12 are 1 and 12. I'm going to do minus 1 and minus 12. I'm going to do minus 2 and minus 6. I'm going to do minus 3 and minus 4. Have the appropriate factors with the appropriate signs. Now I'm going to move on and I'm going to add these. I'm going to do negative 1 plus negative 12. I'm going to do negative 2 plus negative 6 and negative 3 plus negative 4. Because the signs are both negative, you're going to add and keep the numbers negative. So those are the results of my adding. Now I can see the pair that I need because I know I need to get that negative 7. So the minus 3 and minus 4 are going to be what I need. Now I'm going to create my 2 parentheses. I'm going to take the z squared, divide its exponent by 2 and get a z to the first, leave that in my parentheses. And then my side work gives me how I fill in the parentheses. And it never ever matters which parentheses you plug the number in. Having z minus 3 and z minus 4 is no better than writing z minus 4 times z minus 3. Those both would check to the answer that we need to have. Let's do 41 together. So 41, I ask you to factor b squared plus 4b minus 5. First sign is plus, second sign is minus. I need the plus minus factors for negative 5. Larger number positive, smaller number negative. So first step, I'm going to look at that negative 5, and I'm going to write its factors down. Larger number positive, bigger number negative. 5 is a prime number, so those are my only choices. Now I'm going to add these. So I'll do 5 plus negative 1. Because 5 and negative 1 have opposite signs, 5 plus negative 1 is really the same as 5 minus 1, which is 4. That's a good thing because that's what I'm searching for. So the pair, the only choice that I have, actually works. So now I'm going to get ready to factor. I'm going to create 2 parentheses. To fill in the first, I take the b squared, I divide its exponent by 2 and get a b to the first. I put those to lead off my parentheses. Now the numbers with the appropriate signs will fill up my parentheses. One parentheses will get a positive 5, the other parentheses will get a negative 1, and the order that we write the factors in makes no difference whatsoever. So both of these are equally correct answers for 41. Let's do 44. So in 44, I'm asked to factor z squared plus 10z minus 24. 24 is an unfortunate number. It's largish and has lots of choices. Again though, when I go to write down the factors of minus 24, I need bigger number plus, smaller number minus, 1 plus, 1 minus. So factors of 24, I'm going to do bigger number plus, smaller number minus. So negative 24 is 24 times negative 1. It's 12 times negative 2. It's 8 times negative 3. It's 6 times negative 4. Theoretically, you're supposed to just know this in your head and not write any of this down. Usually when I cite factor, I just write the answer down. If I was solving the factoring for this problem on my own, I would just write the answer down because the math that needs to be done, I can do in my head. And really the only math that needs to be done is finding the pair that works. I don't need to check every single pair if I can just by sight tell the pair that's going to work. But because not everyone can see numbers in their head, I show this work. But if you can do this in your head, don't show any of this. This is just for those people that need it. So now I look for the right pair, trying to get this 10. So the pair that I'm going to need are the 12 and the negative 2. I'm going to go to factor this. I'm going to split the z squared up into a pair of z's, leading off my parentheses. My numbers are a plus 12 and a minus 2 in any order. Let's do one of your odd ones. Let's do number 49. So for 49, I need to factor a squared minus 9a. Oh, gosh darn. Trying to figure out how to write my a's so that they're readable, and trying to write it like my niece who's in 3rd grade, who writes better than me. I was going to just make capital A's. So this is the bottom row of my template. So I need plus and minus numbers, smaller one positive, bigger number negative. I need factors of negative 22. So for negative 22, smaller one positive, bigger one negative, those are going to be my choices. I have my factors of 22 written off on my sheet that you're allowed to use on the test. Now I'm going to add these. 1 plus negative 22, that's really 1 minus 22. And 2 plus negative 11, that's really 2 minus 11. Matters not to me how you think of them. The first pair you get a minus 21. The second pair I get a minus 9. So that's the pair that I'm going to need, that second pair. I'm ready to factor. Make my two parentheses. Split the a squared evenly as a couple of a's to lead off my parentheses. One of my parentheses gets a positive 2, the other gets a minus 11. And the order that we write the parentheses in never matters. So you might consistently have your work backwards from mine. Maybe you learned how to factor at some point in another class, and they taught you, they had a preference, but I don't have a preference. Let's do 51 together just to pop out another one of your homeworks, and maybe we'll do 54 on this sheet as well. So for 51, the signs are minus and minus, which means I'm looking for pluses and minus, smaller number, positive. There's no common factors till we get to the third video. I'm going to look at the negative 16 and write down the factors. Smaller one positive, bigger one negative. 1 times negative 16, or 2 times negative 8, or 4 times negative 4. Let me add these. 1 plus negative 16, 2 plus negative 8, 4 plus negative 4. 1 plus negative 16 is negative 15. 2 plus negative 8 is negative 6. 4 plus negative 4 is 0. The pair that I'm going to need in problem 51 are the 2 and negative 8, because that's the pair that gives me the negative 6. Make my two parentheses, split the x squared evenly between the parentheses. One parentheses gets a positive 2, the other parentheses gets a negative 8, and again, the order is never going to keep your answer from being correct, as long as you have one parentheses with a plus 2, another parentheses with a minus 8. Orders are not a big deal. Let me do 54 that's on this sheet. So 54, trying to factor x squared plus 9x plus 5. It's plus and plus, so my signs have to be plus and plus. There's no need to sneak in a minus. So I'm going to write the factors of 5 that are double plus. That's 1 and 5. Done with my first step. Now I'm going to add these. 1 plus 5 adds to 6. I need a pair that add to 9. The only pair that are even permissible are 1 and 5, since I can't find a pair of numbers that do what they need to do, specifically be both plus and multiply to 5 and add to 6. That makes this prime. One more and then we'll move on to our part 3. Let's do 57. 57 wants me to factor x squared minus 5x minus 9. Bottom row of my template, so I need plus and minuses with the smaller number positive. So for my minus 9, I need either a plus 1 and a minus 9, or a plus 3 and a minus 3. Those are the only ones that fit. Plus and minus, kind of smaller number plus. They're tied in the bottom one, but I didn't need, one of them needs to be plus, the other needs to be minus. Now let me add these. 1 plus negative 9 is negative 8. 3 plus negative 3 is 0. I'm trying to find the pair that combine to be negative 5. The only choices I had for the proper versions of -9 can't give me the -5 that I want so badly, that makes that a prime as well. When I can't find a pair of numbers that do what they need to do, then it's prime. So when there's not a number in front of the x squared, there's no reason to group. The reason I taught grouping is because it's going to make section 5.4 easier to teach, and we're going to use the grouping technique. And so having it perfected is not going to hurt at all. So we'll do a part 3, and then we'll move on.